So here we go. We should be ready for problem number 7A. All right, bacteria group. The number of bacteria in a petri dish culture after 2 hours is given by this. B equals 100 E to the 0.693 T. My old eyes are having a hard time. Did I copy that right?
Yeah.
Okay. What is the initial number of bacteria present? 100. So your initial value is always your A. This is A times B to the X. This is your A. So the initial value is 100 bacteria. How many bacteria are present after 6 hours? Plug in 6 for T. So let's all type that in, make sure we can. You have an E button. It is above your LN button. So 100 second LN 0.693 times 6. Did you get, B of 6, did you get 6394 bacteria? I'm going to go ahead and round that off because I don't want to talk about 0.35 bacteria. Right? Did you try to cut that in, Sherman?
Mm-hmm.
Your calculator's upside down. You didn't try to type it in. I want to make sure. Where's your calculator on?
That's what I got. Oh,
Guys, we gotta be prepared for class. Who else am I writing up here? Jack Lockhart?
Nope.
Oh, it's good at 600. You have the X. You still
I can grab it. It's on the card. An unprepared student.
Wait.
You see?
Girls, the girls have calculators.
Yeah, it is.
Yeah.
Get it out now.
Okay.
It should be. You don't want to see her be aggressive. Calculators over.
All right, you guys, come on. Give yourselves a fighting chance. Be prepared for class. Jack Lockhart, how many times did you go to football practice without your pads and helmet?
0.
Exactly. All right. Carbon dating. The amount C in grams after T years is given by, oh my, negative
golly, what a number.
Did I type that number in right? Negative 0.301216.
That looks right.
Okay. What was the initial amount of carbon 14 present? 20 grams. How much is left after 10,400 years? So we're just going to plug in 10,400. Your answer can be small, but it can't be negative, right?
Yeah,
It can't have negative grams. So we're plugging in for this T right here. We're plugging in. Somebody tell me what you got. 5.647 grams. All right, so if you did not get that, let's type it in again. 20 second ln, that's how you get the E, second ln, and then that big decimal times 10,400.
You said it can't be negative.
The output can never be negative because the output represents how many grams you have left. So this number, eventually, this is radioactive decay. So this number is going to get small, but it's never going to be negative because you can't have it.
You say you got this for? That's 20.
Well, you started with 20, so how could you end with 20?
You didn't plug in the value.
Yeah, you have to plug in.
How? Hey.
All right. Next, you did that part. When will the amount left be 10 grams?
So you plug in from what?
So 10 is going to be over here, right? So we're going to have 10 equal to this.
Oh, I get that.
We want to know when that happens. Now, I heard Elijah say, oh, you got to do that LN. Yeah, that would be one way to solve this. So I'm going to go through that with you. We're going to spend a lot more time with logarithms. It's about a whole chapter, okay? But we'll refresh your memories right now. What else could you do though? Since you have a calculator right here, what else could you do? You could graph this equation, right? And then you could graph 10. And at some point, they're going to
Intersect.
cross, right? Okay?
Yes.
So let's do that. Let's try to graph, and then we'll show you how to do it. I'll remind you how to do it with logarithms. But you need to be able to do this problem right now. So if you don't remember how to do the logarithms, you're going to have to graph it. So let's graph it. I'm not sure.
Oh wait, if we're not putting a T in,
What do we put for T? Do we put anything?
you put X for T?
Yes, X for T. Yeah, you're going to put that's your X. That's your X.
I'll for sure have make my last birthday.
Alright, when I graphed, I got T to be 5,700.2235 years.
What was your window?
I'll tell you in a second. Did anybody get that by chance?
Mine was like 2 years.
Okay, so I'll tell you what my window is in a minute, but I want you to hear my logic, because you got to be able to figure this out. So here's my logic. My ordered pairs, my variables, are years and the amount of carbon left, right? That's what I'm talking about. So my minimums were both 0, because I can't have negative years and I can't have negative grams, right? For my Y max, I used because that was my initial value. Right? Now I could have used other numbers, but this is my thought process. Then I paid attention to the problem that I'd already done. After 10,000 years, there were 5 grams left. I want to know, when are there 10 grams left? Right? So whatever my X max years, my X max is, it's got to be up there in the thousands, right? So I think I went with 8,000 or something for that. Because I looked at what I'd done here. This was the 10,000 number. So the answer is going to be about 5,000, and sure enough it was. About half. Okay? So using that window, 0, just do 10,000, 0 to 10,000, and 0 to 20. See if you can get a nice graph and an intersection, right? And you got that number? Okay. All right? Okay, are we ready to do the logarithm part? Guys, you ready to do the logarithm part now? To run through that? So, on the semester quiz, this problem is going to be a calculator problem. Okay? One option you have is to graph it. We just did that, we got that answer. The other option you have is to use logarithms. So here's our equation. This is our equation. Step 1, divide by 20. You've got to get rid of your A value, your initial value. So 0.5, 1/2, equals E to the negative 0.0001216 for X. Okay? Now I'm going to take the natural logarithm of both sides. I'm going to ln both sides. You could log both sides, log, but this is going to be easier because ln is log base E, and when you ln and E, they're inverses of each other. So when you ln and E, they cancel. And all you have left on this side is your exponent, negative 0.0001216. And over here, you have ln 0.5. Since we're solving for t, all we need to do is divide by that big decimal, right? So type it on your calculator, ln 0.5 divided by that big decimal, and it better be that right there. ln 0.5 divided by negative 0.0001216. Sure enough. So either of those ways to do the problem are fine. Either of those are fine. You're going to need a calculator to do it. Can't use a baby to do it. You gotta have your big calculator so you can graph it or solve it with logarithms. Alright? Let's get one more done and then it'll be time to go to lunch probably. Population growth. Using 20th century stuff, we have this equation.
Oh no.
Is that right?
Happy Friday.
Mrs. Mills is wonderful.
She's just telling me. Dr. Coleman,
Oh.
Oh.
Oh,
Well, I got a lot of these clowns in my class. We share a lot of people here.
Good.
Where were you yesterday? Yes, I know you were absent, but it was test day, of course.
Alright, so here we go. P is the population in millions, and T is the number of years since 1800. You guys, you've got to read, you got to know what your variables stand for. So T is the number of years since 1800. So if we're finding the population in 1850, we're going to put a 50 in here. All right, so let's all type that in. Make sure you can. Charlie, I want you to type this in, or I'm going to get really.
I don't know.
Boys, do you have to type in? I know you don't, Jack, because you're on the calculator. So we're typing in this equation, but we're putting in 50 on the T.
29.
Every time I go.
What did you say you got?
I got 29. I took two.
1.79. I got 29. How many points? You guys know over there.
I got 1.795. Okay? Remember, these are millions of people. All right, what will the population be in 2010? Well, you're going to do exactly the same thing, but what are we putting in now for 2010? 210? All right, do the same thing, just putting in 210.
On my list, I took more medicine. I don't even know what I took.
So what did you get for that one? 19,162 million people? Get what you got? Okay. What is New York's maximum sustainable population? This is also called the limit to growth. We know that every population has a max. Whether it's the deer in Fort Harrison State Park, whether it's the fish in the ocean, doesn't matter. There's a maximum for all populations. What would be, do you think, the maximum population for the year. Alright,
The maximum
you
probably
all
would
want
be
to go lunch, right? We need to
like,
answer this question.
maximum probably be like 35 million.
Okay,
Wait, can you choose
no.
graphic?
Here's what I want you to think about. Look at that equation. This ties into what we talked about yesterday. Look at this equation. Of all your BFFs, what is this one closest approximate? What is
Logistics.
Logistic. Your
Oh, there's an
logistic
asymptote.
function has a lower asymptote, that's your minimum, and an upper asymptote, that's your maximum.
So it'd be 19.
What?
19 and 0, right?
Well, close, it would be 19.875 over 1.
Yeah.
Right here is your upper one. So your upper thing is 19.875. So what is the maximum sustainable population? 19.875 million. And then the minimum, as he said, the minimum population is of course 0. That would be the fewest you could have, right? Of course it does. All right, everybody back, 45. Let me get this turned off. So we don't